Hey everyone, it's Mr. Canfield. Today we're doing chapter 7.5, Proportions in Triangles. You'll need a trusty calculator for this. So here we go. And this is my rough draft, so I might have to do some edits along the way. I see there's a problem in number 1, that's why I'm saying this at the beginning. Cool. So we're going to review first and talk about two parallel lines cut by a transversal. Just remember the way that these things worked was if we marked angle 1 with this, remember that angle 3 also matches it, right? Because they're vertical angles from each other. But the special thing is, since these are parallel lines, 3 and 8 are the same, and 1 and 5 are the same. And this is where the typo, like 5 and this is 6 right here. But these four angles are all the same. So we know that 1 is congruent to 2 is, nope, that's not 2, it's 3. 1 is congruent to 3, which is congruent to 8 and 5. So 1, 3, 5, and 8 are all the same. And the same goes for 2, 4, 6, and 7. 2 is equal to 4 is equal to 6 is equal to 7. And the other special trick with all these things was the interiors like this, 4 and 5, the interiors on the same side interior angles, or same side exterior angles. Any pair of these, so like 1 and 7, 4 and 5, 3 and 6, 2 and 8, those are all supplementary. They add up to 180. So we know like 1 plus 7 equals 180, or 4 plus 5, or 3 plus 6, 2 plus 8. And the last one we should talk about, what about 4 and 6? This was a special situation. We had 4, 6. Those were called alternate interior angles. Now, we did already say they were equal to each other, but that was just an extra special case to talk about. Okay, so we're going to take these ideas and bring them into a triangle. It says, the triangle shown was created by dividing one side into 4 congruent segments. So this, 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 and this are congruent, and drawing lines parallel to one of the other sides. So then we know that this is the little symbol that means parallel, right? I drew it on the previous one, and now it's on here. So we have these parallel lines. And so we have parallel lines cut by a transversal, what word am I trying to say? Essentially, that's the word. So how many similar triangles are there? Well, let's look. If we look at this like baby triangle here, it has this angle, and then this triangle here also has this angle, and then this triangle here also has this angle, and then this triangle here also has this angle. And since we have these parallel lines, and this is a transversal, this is equal to this, is equal to this, is equal to this. All of these are the same angle. Well, hey, that means by angle-angle similarity, this guy, this guy, this guy, and this guy, they're all similar. So we have 4 similar triangles. How are the lengths of the parallel segments related to each other? So here's a special thing, right? Since we have 4 similar triangles all layered off of, this kind of tiny one up here, or we have the big one with like the sections that make 4 total, 1 big one and 3 smaller ones, however you want to look at it. Well, that means that the scale factor is going to be consistent. So if we called this like 1, I don't know what it actually is, but if I called this one 1, well, how long would that side be in this second biggest triangle? It would be 2, right? In the next biggest triangle, it'd be 3, and in the absolute biggest triangle, it'd be 4, if that was 1, whatever it is. But each side is one more portion. So if we called this one A, this would be 2A, this would be 3A, and this would be 4A, right? The scale factor would be identical. So I'm just going to go over there. We don't need to actually write that in words, but the scale factor that happens here on these sides would happen on those sides as well. And this leads us into our first theorem today. It's a really funny theorem. It's called the side splitter theorem. It's so funny, it splits sides. Sorry, that was bad even for me. So if we have a triangle and then there's a parallel line that's parallel to the other side, what it does is, look, it says AM right here, and then it compares it to MB. It then shows that this piece is proportional to, or is in the same ratio as that one. So like if this was 1, 2, 3, and 4, that says you put 1 and 2 together, and that's the same as 3 and 4 together. Not the numbers 1, 2, 3, and 4, just sides number 1, 2, 3, and 4. So, and there's other things we can do too. And we don't actually need to know this theorem to do this one here, but it lets us do like example 4 really, really easily. All I have to do for example 4, I have this piece, this piece, this piece, and I don't know that piece. I could just set this up. I could go 12 goes to 16 equals, I did that one to that one, so I needed to start in the same spot. X goes to 24, and now we'll just do the butterfly. So 16x is equal to whatever 24 times 12 is. Oop, 24 times 12, 12. So 288, and then so we'll just divide by 16, and I get x is equal to 18. So it lets us just do that, which is pretty sweet. As long as those are parallel, this works. So we'll come back to number 3 in a minute because it's more complicated. So if I look at this, it says AD is 3, so if I go from A to D and I put a 3, then CE is 6, BE is 8, find BD, X, boom. So now, you know, it's just, it wasn't marked for me, now it is. So I can do the same thing. I can do 3 goes to X, 6 goes to 8. I could have done X over 3, 8 over 6, that's fine too. But now if we cross multiply, let's see, 3 times 8 is 24, x times 6 is 6x, 6x equals 24, divide by 6, you get x is equal to 4. And you think I'm going really fast. Sorry, I'm just trying to get this done as fast as I can. Feel free to, you know, you can always rewind the video. So let's look at number 3. The challenge with 3 is I don't know x or this piece, I just know the whole thing is 9.6. So what I can do for this is I could do little triangle and then compare that to big triangle. So like I could say 3 goes to the whole side here, which is 3 plus 5, which is 8. The whole side would be 8. And then I'll compare that to x is my little side, and then my big side is 9.6. So it's you have to think a little bit more for these. You can't just use that setup that will work every time. So 3 times 9.6, everybody knows that one. Get it? I'm using my calculator saying everybody knows it. Haha, I'm so funny. So I get 8x is equal to 28.8. Now I'll divide by 8, divide by 8, divide by 8. I get x is equal to 3.6. All right, all right. Cool, so let's keep going. So then you get to this one. This one looks really complicated, but it's the same idea, right? It's broken up into these pieces. I can take one piece and compare it to another piece. So I could say, whatever happens from, since those two are parallel. This one doesn't say it's parallel. I'm pretty sure it's supposed to be parallel. Otherwise, maybe, you know what? I meant to say it's parallel. It's parallel. So if I do x plus 2 and 4, I could do 4 to x plus 2 or x plus 2 to 4, it doesn't matter. Whichever way I do though, so let's say I do 4 to x plus 2. Then so I did that to that. Then on the other side, I have to do 3 to x. I have to do the same order. And this one looks like it might be a little bit weirder to start out. Well, we'll get 4x is equal to 3x plus 2. So we have x on both sides. And we used to deal with these a lot more. This is 4x, but there's no plus number. It's plus 0. This is 3x plus 2. Remember, we want to get the x's on the same side of the equal sign. So I'm going to subtract 3x from both sides to cancel it out over here, and we'll be left with a 2. So 4 minus 3 is 1. I get 1x is equal to 2. Oh, okay, so x is 2 now. So I am asked to solve for y. So I can't do like piece and piece because I have whole sides here, but I could look at little triangle and then big triangle. So in little triangle, I could look at 12, and then in big triangle, 12, 16. If x is 2, that's 2 plus 2. This is 4 right here. So 4, boom, boom, this is 20, right? Because it's 4 plus 4 plus 12. I added all those up. So I can do 12 to 20, and that has to be the same as y to 30. So 12 to 20, y to 30, and now I can just multiply, so I get 20y is equal to 12 times 30, 360, and I'll divide by 20, and I get y is equal to, is that 18? 18, yeah. So now I know y is 18, and to finish this up, I'm supposed to solve for z in the last one. So I could do the same kind of thing, right? I could do 12 to the whole side of this medium triangle. So I could do 12 to 12 and 4 together is 16. And that's going to be the same as y to z, which is y was 18 and z was z. We don't know z. So I'll get 12z is equal to 16 times 18. 16 times 18, 288. So I'll divide both sides by 288 or by 12, and I'll get z is equal to 24. And let's see, does that number make sense? Oh, excuse me. Oh, sorry about that. Well, 18 is the smallest, 24 is in the middle, 30 is the biggest. Yeah, that works. Yeah, that's a sensible thing to say. All right, so one of the cool things you can do with this is even if you cut off the top of the triangle, it's the idea, the relationship is still there. So what if we had this shape? You might not know what this shape is called. When we have two parallel sides and then two non-parallel sides, they call this a trapezoid. But if you look, if we just extended it a little bit more, we'd have a triangle. And these are all parallel. They're all parallel to Lincoln Street, as said in here, and Jefferson Street. So they're all parallel to each other. The city wants to add additional tiling around the pool. How much tiling does X feet represent? So they want to add some more tiling. I'm pretty sure in the color version of this, this is a pool instead of just a grayed out piece of land. So if I'm trying to do this, then, well, I can just do like this piece to this piece, and then this piece to this piece. So I could do X to 24 is the same as 60 to 72, because the relationship is preserved. And so now I'll cross multiply, I'll get 72x, and then 24 times 60, 1440. Divide that by 72, I get x is equal to 20 feet. So how could I find y? Well, I could do the same thing, right? I could do y to 72. I did that to that, so then I could do 24 to 60. So I'll get 60y is equal to 24 times 72, 1728, and then I'll divide by 60, and I get y is equal to 28.8 feet. So my confidence has just disappeared on me. I am now fearful that I did something wrong. I'm just going to open up the lesson really quick and make sure that I didn't make a stupid mistake. Oh, I'm so sorry I coughed that loud. Please forgive me. Please forgive me. All right, let's see. So, just double checking really quick. All right, cool. Something I forgot to do is, since this is a real world situation, we do want to write feet because these are working in feet. So make sure you do that. And I have a special guest right now. Did you have any questions for me, anything? All right, cool, I'll see you later. And my special guest sometimes watches my videos. So hey, special guest, it's good to see you. Doing a good job, keep it up. All right, let's continue on to our last page. So the last page of the notes today, it adds in an extra that it's related, but it's not quite the same. So this one says, in triangle KLM, NL bisects this angle. So you can see it's got the little markers to show that these two are the same angle. Compare the ratios of KN and MN. So let's see, KN to MN, KN to MN, that's 10.5 to 7.5. How does that relate to KL to ML, 14 to 10? Let's see, 10.5 to 7.5. This is 1.4, and 14 divided by 10 is also 1.4. And so you might be like, oh, cool, we have similar triangles. Similar triangles, we need to have AA, SSS, or SAS. The thing is, I don't know that angle K and angle M are the same, so I can't do SAS in there. And that angle, oh, excuse me, that angle there, that would make it ASS, which is one of the ones that we're not allowed to use. So I guess I should just check. They have a third side, don't they? They have NL. We don't know how long NL is, but each triangle has it. So what would NL to NL be? Whatever this is, any number you want, pick a number, divide it by itself. What do you get? You get 1 every time. Well, look at this. We got 1.4, 1.4, 1. The three sides don't have the right proportionality. So no, this is SSS, but the third side failed. So I'm going to cross that out. So only the first two sides worked. So, but this leads us to a special theorem, and that special theorem is if you have an angle bisector, this always happens. These two and these two are the same proportion to one another, even though it might not be similar triangles. It is possible to have similar triangles, but it's only in a special circumstance. So, so it says UX, and so UX to WX is the same as UV and WV. So, and you can do purple to purple, or you can do purple to yellow, as long as you do it the same way each time. So here on this one, I see this is 13 the whole way, and I see that's X. So the first example we have here is a little tricky, and I'll show you how we, let's start with the easy one. The easy one's at the end here. We have this angle bisector, so I'm able to say 2 goes to 3.5, right? 2 goes to 3.5 in the same way that 7 goes to X. You just have to start with the same triangle both times, or start with the same position both times. So 2 times X is 2X, and 3.5 times 7 is some decimal. 24.5. And we'll just divide both sides by 2, and we'll get X is equal to 12.25. And again, I'm just double checking that I'm not making some silly mistake, that I'm underthinking something. I would hate to have underthought this. I'm going to correct it in the video if I made a mistake, but I'm pretty sure, yeah, we're good. All right, so up here, number 11, I can do 16 and that have to be, oh, wait, I don't know that. Oh, I can do 10, I'll do 10 and X. I know 10 and X, right? Let's say 10 goes to X, and that has to be the same as 16 going to this. And here's how we find this. I know the whole thing's 13, I know that's X. So that means that this right here is 13 minus X. That's a fancy way that we can go through and do that. So I'm gonna be very careful when I solve this, because this is gonna use all of our smarts. So I'm doing 10 times 13 minus x here, and that's equal to 16x. So when I do this, I have to distribute this. So 10 times 13 is 130. 10 times x is 10x, and it has a minus, so minus 10x. So now I will add the 10x to both sides. I get 130 is equal to what? 16 plus 10 is 26x. So I'll do 130 divided by 26, and I get x is equal to 5. So the way I can double check and actually see if I did this right, well, then that means that 10 to x, which is 5, should be the same as 16 to 13 minus x, which is, well, if that was 5 and this is 13, that's 8. 10 divided by 5 is 2, 16 divided by 8 is 2. So it did work. And lastly, we'll do number 12. I know we did these in a little bit of a different order, but it was because that was the least and that was more complicated. To finish it up with 12, I can either do this to this, or I could do this to this, this to this. It won't matter. It will work the same every time. As long as you start with the same triangle every time, and then you pick your convention and stick with it. So I could say 3x plus 3, and then put that with 18 is equal to 3x minus 7, put that with 12. Or I could say 3x minus 7, put that with 3x plus 3, and then do 12 and 18. And it will work the same, I promise. Because look, 3x minus 7 gets multiplied by 18. 3x minus 7 gets multiplied by 18. The multiplication that you do winds up being the same as long as you set it up correctly. So we have to distribute here, so I'll do 12 times each of those. So 12 times 3 is 36, and 12 times 3 is 36. So 36x plus 36. 18 times 3 is not something I generally remember. Is it 54? So 18 times 3 is 54, so we get 54x, and then 18 times 7 is 126, and it has a minus sign, so minus 126. So I'll do my normal solving. I'll subtract 54 from both sides, minus 54x. 36 minus 54 is negative 18. So we get negative 18x plus 36 is equal to negative 126. We'll subtract the 36 from both sides, and I'll get negative 18x. All right, so let me say negative 126 minus 36, and then we'll divide that by our negative 18. And I get x is equal to 9. Okay, so you can have some heavier problems on these. We're definitely gonna do some practice before we have a test. This is the last section in the unit. Hope it was helpful. As always, my name is Mr. Canfield. I hope you're having a great day. Bye.